Hi everyone and welcome back to our friendly tech chats. We're here with Bart to talk about his interesting experience that he had with the chaos engineering.
What we did was we organized a chaos day, so little context. I'm in the SRE team, which tries to push reliability best practices to everyone at Bol.com. The season is coming up, November, December. That's like a third of all our sales and double the traffic at least, I think triple for some cases. And more actually, Black Friday. We wanted to put a little emphasis on testing the resilience of our systems. And one of the ways that we did this is organizing a chaos day where we give everyone the time and the tools to do chaos engineering together. So, what is chaos engineering?
Yes, what is
Um,
chaos engineering to start with?
exactly. So, the I think conceptually, it's the controlled injection of faults into production in order to verify that system's resilience to those faults. And it doesn't necessarily have to be into production, actually. It's just the controlled injection of faults into a software system in order to verify the resilience of that system.
I'm curious, then if it's not on production, then it's not very much different than normal testing of resilience, right? You can apply these techniques also on
Yeah.
non-production environments, and
Yes, exactly.
that's fine. And maybe you can even test those techniques and recovery before going to production in the more critical passes. But
Right.
I guess the real gist and thrill of the chaos engineering when you put chaos into real production systems.
Yes, exactly. I agree, but we haven't managed to convince everyone at Bol.com of this yet.
Okay, so now it's like on production, sometimes on production environments, sometimes on non-production environments.
Yes, exactly.
But
Yeah.
still, I guess okay, if you do those exercises, it's useful also on non-production environment. Just usually, I guess, a little bit less useful.
Exactly. Yeah, it's definitely more useful on production environments because you will not find the faults that your actual production environment will have. It's just, of course, you do need to have room for these errors that you're injecting. So that's where the control part comes in, and that's where an error budget is really useful. It's like if you have error budget to spend, doing chaos engineering tests is a really valuable way of doing that.
Okay, so here it nicely adjusts to the idea of SRE error budgets,
Yes.
defect budgets.
Yes.
That means that you have it very explicit that you can afford it, or you can say, well, it's it's uh it's up. We don't have any budget left, and that's why we're not doing this month, for example, those exercises.
Yes.
But
Exactly.
that's probably a very good indication that you need to invest more in
Yes,
addition to
exactly. And maybe
what.
then you need to do a bit more resilience testing on your pre-production environment if you've run out of entire error budget on your production environment. And it's actually like a double-edged sword in a positive way. Like because on the one hand, you can use your error budget to do these chaos engineering exercises. But the fun thing about error budgets is that if you don't spend them, then your consumers will assume you are more reliable than you guarantee. So that means that actually your error budget shrinks uh, while you haven't, while you're not defending that smaller error budget. So um, if you're not using them, chaos engineering is a perfect way to force yourself to use them.
And what were the tools that you guys were using or providing, and what kind
Yeah.
of chaos injections were there?
Yeah, so it was all based on a Kubernetes environment in the cloud, and then in DC there was just a Terraform managed environment, I think. But we had connected both these clusters with an Istio service mesh. So we used the native Istio fault injection mechanism, um, which means that it does client-side um, error injection and client-side latency injection. But when I say client-side, I mean on the Envoy proxy that runs at the calling side.
Okay, so that means that when there are two services and there is a communication, the client side will get it goes through the Envoy proxy, and there the injections, the delays or timeouts or maybe even error responses.
Yeah, exactly. Error responses as well. But the way like the service mesh works is that every node, every pod in the service mesh gets their own Envoy proxy. So the client calls its own Envoy proxy, which calls the server's Envoy proxy, which calls the server. And then the faults are injected in the client's Envoy proxy.
And is this only about service-to-service REST communication, or you can also inject faults into messaging, pops up databases?
Yeah, well, Istio, of course, doesn't. Pops up basically just uses gRPC under the hood. So I guess you can inject faults into those gRPC calls. But more interestingly would probably be to inject faults into the contents of the message, maybe. Um, I don't know if you talk about a generic queuing system, asynchronous fault injection.
Okay, yeah, that's maybe slightly.
Yeah,
Well, it
it's
is
not
interesting
supported.
for
It's not
publishing.
something we did. Yes.
It is
Okay.
interesting for publishing, especially for high volume publishing that you are
Yes, exactly.
recovering.
But then you're basically just injecting faults into your publish calls, right?
Yeah.
Which for PubSub at least is just gRPC or HTTP.
Yeah, okay. Well,
But
if you don't
yeah,
do that, my question was whether you guys were doing that or not.
yeah,
So
we weren't
I
doing
guess
it.
no. It was mostly
The other
focused.
tool we're using,
Yeah.
let's go there, is KubeMonkey, which is one of the Simian army specifically tailored to Kubernetes. And basically, what that does for us is that it randomly shuts pods down, which is also a fun way of doing chaos engineering.
So you said that you guys were doing it on with some teams on non-production, with some teams on production. What were the findings? Was there something interesting? How was the vibe? How was the
Yeah, so quite a few findings were between front end and back end. Like if there's delay in the back end and the front end doesn't properly handle it. But there was also in the checkout fleet, which was of particular interest because they had a rather cascading failure a couple months ago. So they were quite keen to verify that they had fixed that unresiliency. And what they found, their graceful degradation was not graceful in certain combination of faults. So each individual fault was properly handled, but if two faults would happen at the same time, then that would not be handled properly. And I thought that was a really interesting finding because that's particularly one of those things that you have to hunt for, you know, because it will happen in production, but when you're testing it, like just going through test cases, you probably won't find it.
how was it organized with the time slots and how was it tested? Like manually, automatically monitoring?
Yeah, manual. Like time slots, it's just we organized a day and then we started with some presentations. This is what we're going to do. And then there was like a support team available for the day and people could ask questions and do their experiments. And at the end of the day, the conclusions of the experiments were presented.
So it was like a hackathon, a chaos hackathon.
Yes, yes, it was very much like a chaos hackathon, only like specified like the hacking that you're gonna do is injecting faults into your own system.
What is your opinion? Should we always strive to do the chaos engineering on production?
I think chaos engineering is the step that comes after doing SRE, right? So first you need a proper indication of what your reliability means. And once you have that, you need to use chaos engineering to defend that from the other side. So you use proper incident management and slowing down when you're consuming your error budget to defend it from the bottom up, and use chaos engineering to defend it from the top down, but also to find the harder problems from the bottom up before they become bottom up problems.
Well, I'm not necessarily convinced that you necessarily have the fully fledged SRE to do chaos engineering, at least on some level.
No, I'm not saying you need a fully fledged S3. You need proper observability.
Yeah, you need observability. You need to
Yes.
know that you need to have faith in your production systems
Yes.
to inject
Yeah.
this. And I guess that's, for me, would be a reason to push towards generally more chaos engineering on production. Not that much of the chaos engineering, but because the fact that we can do that.
Yes, exactly.
Not in
It
YOLO
is,
way,
yeah.
but like really, yes, we can do that. Let's do that. That's
Yeah.
indication of a good health of those services. So if we
Yes,
can't
because
do that, if there are other reservations, then it's good reason to check and see what are the weak spots.
yeah, exactly. Pushing for chaos engineering is basically asking the question, how confident are you in your production system? And if that answer is, we are so confident we can do chaos engineering, then you're in a really good spot. And that chaos engineering will put you in an even better spot. But if the answer is, I'm not sure, then already you've got profit from the fact that you're asking for chaos engineering.
Yes, that's a good indication. I'm not sure. Maybe it's even worse than when someone says, no, we have enough problems, we don't have enough budget. When I'm not sure,
Yeah,
then, okay, we
exactly.
don't know. we have no
Yeah,
clue.
exactly. So why are you not sure? What do you need to get to figure it out?
Are there some type of the services, type of the functionalities that benefit more from chaos engineering approaches than others?
I think if you have a long chains of responsibility, as in microservice, customers, then chaos engineering becomes really, really valuable. Because that is where those cascading failures creep in and never get tested, because a couple of teams are responsible for this and a couple of teams are responsible for this. And then if you never test the connection here, then you will find out that there's something wrong with that only during an outage. So I would say the longer your chain of responsibility microservice-wise is, the more valuable chaos engineering is.
Yeah. I would say also that when consistency is important, it might also be a secondary case for me, at least. I used to work in teams.
As in data consistency.
Consistency, messaging, microservices consistency.
Right. Yeah.
And then the indication for me, for example, was that we are not in a good spot when we were trying to avoid high loads for deployments, because a deployment is a sort of a little bit of the chaos injection.
Yes,
very soft, but it is a chaos injection.
Yeah.
And when we were trying to avoid the high volume spikes or batches, then it was a good indication.
Yeah, I could say generally the value of chaos engineering is directly tied to the requirement for resilience. Like if you have a high consistency requirement, in essence, that's a high resilience requirement.
Yeah, that's definitely an important resilience requirement. Yes, I agree. And the same for the cascading services. So what can we negate from this? So if your service doesn't care about resilience, something like a helper tool that publishes something not very important, and it's okay to lose lots of data from time to time.
Yeah, like reports that get generated once a day from data that it doesn't own. You know that. Those kind of things that can have an outage and be out of there, and maybe idempotent messages that get so many updates that a couple of mistakes auto heal essentially. That
yeah, unless they don't for one message, but okay.
Yeah. I mean, if you rely on that kind of resilience, essentially, then you need to verify that as well. So maybe in this case, that's the type of resilience that you actually do want to test. I can wholeheartedly recommend everyone to do this because it'll give you both confidence and insights in production and in your systems in general that you never had before.
Yes, and I would add that it's okay to be careful about chaos injection, but just remember that chaos will be on production and it will be uncontrolled, so it's better to
Yes.
discover it in a controlled manner.
Yeah. This is
Same as testing
exactly.
on production.
Yeah, exactly. And also like one more stab at our platform team is like they didn't enable KubeMonkey on production. I was like, but our pods are already randomly being taken down on production. We need this on
Yeah,
production.
maybe that's why
So
they need to enable. Say, well,
ex-
they are going down anyway, all the time.
no, yeah. So all right, that was awesome. Don't forget to like, subscribe, and share because the algorithm likes that, and that means that we get more fun interactions. And let us know what you think about chaos engineering. Do you do it at your company? Are you gonna try it now, or do you want to hear more about it?
Or
Let
do you
us
have
know.
concerns about chaos engineering?
Exactly. Yes.
We would like to hear about that. Yes.
Awesome. Have a nice day.